Good evening. I had some students emailing me about linear inequalities and when the sign can change and when the sign cannot change. So I want to go over a few examples of that to hopefully help with those questions. So when we solve linear inequalities, for example, if we have something like x plus 9 is greater than 2, if we're going to be solving that, then we want to solve it just like any other linear equation. And so what I mean by that is that we're going to treat that inequality symbol just like an equal sign, except for one situation. So here I'm trying to isolate the x, so I'm going to subtract 9 from both sides. And so when I do that, I have x, this we're just kind of ignoring for a little bit, greater than 2 minus 9 would give me negative 7. And now this has been isolated completely on the variable. So this is a solved linear inequality. So this is saying that x has to be greater than negative 7, and so that means that the smallest that x can be is really, really close to negative 7, but not including negative 7, so we'll put a parenthesis around that. And it can go all the way up to as large as it wants to be, so up to infinity. Again, because infinity does not have a set value, we cannot include it, so we will put parentheses around that as well. If we have something like 7x is less than or equal to negative 28, for example. Again, if we just sort of ignore this symbol for a little bit and treat it like an equation instead, our goal is to isolate the x, to get the variable all by itself. So x is currently being multiplied by 7. To undo that multiplication, I will have to divide by 7. And if I divide one side by 7, I will have to divide the other side by 7 as well. When I do that, 7 divided by 7 gives me 1, so I get an x here, which is what I wanted. Less than or equal to negative 28 divided by 7 should give me negative 4. And now I have my variable all by itself, and I have my value on the other side, and so I can use this to give my set of values for my solution. So I want x to be less than or equal to negative 4, which means the largest that x can be here is going to be negative 4, and then from there it's going to go off in that left-hand direction on a number line towards negative infinity. So the smallest it can be is negative infinity. Because I do not have a set value for infinity or negative infinity, I will continue to use the parenthesis. My inequality had the inclusion by having that less than or equal to, so I'm going to have my negative 4, and I'm going to use my square bracket to include that negative 4. If we had something that looked more like negative 6x plus 5 less than or equal to negative 13. Sorry. So here again, my goal is still to get the x by itself. I can't take care of that division yet because all of these don't divide evenly by 5. So instead I'm going to work with this 5 first. I don't want to be adding this 5 to this 6x. So I'm going to go ahead and subtract that 5 from both sides of this inequality to give me negative 6x less than or equal to negative 13 minus 5 would give me negative 18. And then here I can go ahead and do the division like I did in that second example, only here I'm not dividing by 6, I have to divide by negative 6. And when I'm dividing by that negative 6, here's where I do have to worry about that sign, that inequality symbol changing, because in this situation we're not going to think of this as a negative 6, we're going to think about it as the opposite of 6, and so everything in this equation has to become its opposite. So negative 6 divided by negative 6, this whole thing is no longer going to be negative, it will become positive, so I have a positive x. The numbers over here, negative 18 divided by negative 6, again this makes the whole value right here opposite, so it's no longer going to be a negative value, it's going to be a positive value. I get a positive 3. And these guys change to their opposites, which means I also have to change my inequality symbol to its opposite. And so it's no longer going to say less than or equal to, it's going to say greater than or equal to. So my solution here is that x is going to be greater than or equal to 3. The only time I flip this symbol like this is when I have to divide by a negative number. On this example over here, I had a negative value, but the number that I was dividing both sides of the inequality by was not negative, which is why this sign did not change. Here I also worked with what looked like a negative value, but this was not division, this was just subtraction. So again, the sign does not change. Only when we are dividing both sides of our inequality, or all sides if we have a double-sided inequality, by a negative value, that's when this sign changes. So we have now x being greater than or equal to 3, which means the smallest that x can be in this situation is 3. It does say greater than or equal to, which is why we're going to put that bracket to include the 3. That means x gets to be as large as it wants, so it's going to go off to infinity, and I'll put a parenthesis around that. I hope that it answers your questions. If you have any more, please let me know. Thank you.